Hello there, welcome to the AS Maths Pure June 2023 paper. Here we're looking at question 15. The curve C1 has this equation here and the curve C2 has this equation. Verify that when x equals 1, the curve C1 and C2 intersect. Okay, let's get started on this question then. So if we're given the x value of when they intersect, what should be able to happen is then when we substitute in x equals 1 into both of these equations, if they intersect, we get the same y value out. So for C1, when x equals 1, y equals 8 minus 10 lots of 1 plus 6 lots of 1 squared minus 1 cubed. Bung that in your calculator. 8 minus 10 is minus 2, add 6 is 4, minus 1 is 3. So 3 is the y value. And it should be the case that we get the same y value when we substitute x equals 1 into the C2. So y is going to equal 1 squared minus 12 times 1, add 14. So let's do the positives first. 1 add 14 is 15, minus 12 is 3. Lovely, there we are. So therefore, intersection at 1, 3. So there we are, that's the answer for part A. Let's now move on to part B. The curve also intersects when x equals k, and k is a negative number. Use algebra to find the exact value of k. So in this case, we will need to set the equations equal to each other. That's what you usually do when you're trying to find an intersection point. Equals x squared minus 12x plus 14. What we're now going to do is move all of that algebra onto one of the two sides, and then we're going to use the fact that x is equal to 1 is one of the solutions. Looking at the x cubed, I'd prefer that to be positive, so I'm going to move everything onto the left-hand side. So we're going to get x cubed minus 5x squared, add 10x, that would be minus 2x, and then take away 8, so that will give plus 6. Okay, we know that it intersects at x equals 1, so if it intersects at x equals 1, then we know that x minus 1 factorizes this cubic expression here. So let's see what we'd get in the quadratic that remains. So we need to think, when we expand these two brackets, we're going to get this line above. So x times something gives you x squared. So that gives you x cubed. So x squared is needed in the bracket to give you the x cubed. Let's expand the brackets as we go down below. So x cubed, then we get a minus x squared from the minus 1 times the x squared. We want minus 5x squared though, so we want another minus 4x squared. So I think it would be best to put another minus 4x here, because then that minus 4x will multiply by the x to give you minus 4x squared. Then if we were to multiply this minus 4x by the minus 1, we get plus 4x, and we actually want minus 2x. So therefore we need to take away 6 more x's. So we'll need to put minus 6 here. So then we can expand this minus 6 with the x to get you minus 6x. And then minus 1 times minus 6 gives us positive 6, which is absolutely correct. So there we are. So this is our factorization. What we're then going to do next is solve this quadratic here. And I don't think it solves particularly easily. We need to use the quadratic formula to help us solve this. So our next solutions from this bracket, from the quadratic bracket, is going to be 2 plus or minus 10, 2 plus or minus root 10 when you put that into the quadratic equation solver. And now what's the value of k going to be? Well, if k is negative, then k is going to equal 2, so it's x equals 2 plus or minus root 10 from the calculator, but specifically k is going to be 2 minus root 10. There'd also be another solution of x equals 2 plus root 10. So in this question, the three solutions are 2 plus root 10, 1, x equals 1 is a solution, but the value k that we want to find is 2 minus root 10. So there we are, that's the answer for question 15, worth a total of 7 marks. Let's now move on to question 16.